Testing is important, no matter what you're working on. If you write Java code, you need to test it. If you're managing infrastructure, you need to test it. If you're working with IoT, you need to test it. There is no excuse not to test while working and before moving it to production. Testing while working allows us to work more efficiently. Testing before moving something to production allows us to have confidence that it will not explode. Now, today's session will not focus on all the ways we can test something. I will not go into mad rant explaining the importance of test-driven development, test automation, CI/CD pipelines, or anything else related to testing. Instead, today I want to focus on testing Kubernetes resources. Most people just write Kubernetes manifests directly as YAML or package them into Helm charts or customize or whatever else we might be using. Once it is done, those people would just deploy that something to a Kubernetes cluster. That strategy tends to be successful if you're religious, since it relies on prayer to the deity of choice to be successful. Dear God, bless those resources and let them be successful. I have no idea what will happen, so I will rely on your infinite wisdom. Good engineers test everything, all the time. They test continuously while developing, and they test through CI/CD pipelines after pushing to Git. The former allows us to write code faster, and the latter gives us needed confidence. Now, when I said that good engineers test everything, I mean everything. And that includes Kubernetes resources. However, we have a problem. When testing is concerned, the situation with Kubernetes is pathetic. We do not have many tools that can help us test Kubernetes resources. We certainly have a plethora of tools to test applications running in Kubernetes, but we do not have much to test Kubernetes resources themselves. But there is hope, or to be more precise, there was hope that died. A while ago, we got Cuttle, or Kuttl, Kuttl. I already explored Cuttle in that video over there, so I won't go into details right now, right here. Watch it if you haven't already. The link is in the description. The problem with Cuttle is... No, wait. It would be easier to explain what is not a problem with Cuttle. The main positive thing about Cuttle is that it exists. It's one of the few, if not the only tool of that kind, thus making it great simply because there is nothing better. Cuttle is a project that is not maintained. The last release was published over a year ago. That, by itself, is a huge red flag. On top of that, it is missing too many features that I feel are critical. I, for example, am in a desperate need of a mechanism to patch or update existing resources. I need some form of templating to avoid repetitions. I need better outputs, and I need some form of catch mechanism that will allow me to execute additional steps when a test fails so that I get more information about the failure. That's my list of missing features, and I think I found a replacement that meets all of those. And that replacement is Kyverno Chainsaw. Just as my complaints and requirements are the result of frustration when working with Cuttle, Kyverno folks faced similar obstacles. They needed a tool to test Kyverno. They used Cuttle, and they quickly hit the walls that prevented them from doing what they needed to do. But there's a big difference between me and Kyverno folks. While my disappointment with Cuttle resulted in me crying at night, they did something about it. They tried contributing to Cuttle, but that did not work out for a variety of reasons. Then they decided to create a new tool, a new project, and that is today known as Kyverno Chainsaw. It's great. So let's see it in action. I'll take a quick break here to introduce you to Checkly, the sponsor of this video. One of the features of Checkly is synthetic monitoring. Now you might not have heard about synthetic monitoring, so let me summarize it for you. Synthetic monitoring, also known as active monitoring, runs automated scripts or tests that simulate the real user actions or behavior to identify and fix the availability, performance, and functionality issues before end users notice them. It's all about finding out that something is wrong before your customers find out. And that's not all. There are plenty of other features. Please check them out. Thank you, Checkly, for sponsoring this video. And now let's get back to the main subject. Here's what I do when I want to start working on this particular repository. That command run all the tests related to that project, which, by the way, are a few cross-point compositions. I mean, that's irrelevant for this story, though. I would run similar set of tests for any type of Kubernetes resources. Actually, that's not true either. I do not run tests like that, but instead I run them through task, which executes tests every time I make a change to my Kubernetes manifest or tests themselves. But that is also beyond the point. What matters is that I can execute tests whenever I want to validate any of my Kubernetes resources, and I can execute something similar from pipeline builds triggered when I push a change to a Git repo. By the way, if you're not familiar with task, you should be. You can watch that video over there to get familiar with it. It's absolutely awesome. I love it. Now, if you're familiar with Cuttle, you might be thinking that Chainsaw is the same, just with a nicer output. If that's what you're thinking, you're wrong. Chainsaw is so much more, and we can see some of that by exploring one of the test definitions. Just as Cuttle, Chainsaw allows us to run tests based on naming conventions, where applying resources and testing them is executed based on file name ordering and with assets always being named asset. However, with a test manifest like this one, like that one, we can gain more control over what is executed, when it's executed, what something does, and so on and so forth. At the very top, I'm specifying that Chainsaw should expect some files to serve as template. Further on, there are two bindings. In this specific case, hyperscaler is set to AWS and cluster to EKS. Templates and bindings allow us to avoid repetition. In my case, there are manifests for Azure, Google Cloud, and as we can see in this example, for AWS. Since those are often very similar with only changes to a few values, I could define all three providers once and let Chainsaw replace those bindings with actual values. That's in a way similar to what we would normally do with Helm or any other templating engine. Further on, we have the try section that starts with the instruction to apply whatever is defined in common install YAML. So let's take a look at that file. This is where I'm using bindings we saw in the test file. Since all three variations are similar, instead of defining three separate files to apply them, I have this one manifest that uses Chainsaw bindings and functions. For example, the name of the secret should be MyDB AWS password for AWS, or MyDB Azure password for Azure, and MyDB Google password for GCP. So instead of hard-coding those values, I'm using the join function that combines hard-coded MyDB and password with the hyperscaler value defined in test bindings. We can observe a similar situation with SQL claim spec ID field that contains a similar join function as the value. Then there is provider that only has the hyperscaler value. As I said, that's similar to what we would expect with something like Helm templating. Now, just to avoid confusion that might lead you to say, hey, but why don't we use Helm templating instead of Chainsaw syntax? You'll see later that there is much more to it than simple templating. Now, to be clear, that join function, that one over there, and many other features of Chainsaw can look scary. The reaction might be, this is silly, or this is too much to learn, or this does not make sense. I should write tests in a different way. Those are some of the thoughts I had when I saw Chainsaw for the first time, and will comment on how I feel about them now near the end of the video. Later, not now, later. What we will do right now is to go back to the test manifest and see what else I have over there. After install YAML is applied, I want to perform some tests. Some of those are fairly similar no matter whether they run for AWS resources or something else, while others are very specific to AWS. To solve that, I have two assert entries. The common assets are in the assert install YAML file, so let's take a look at that one first. This one uses the same join function as before, but this time it is used to generate the assert manifest. The final output is what is compared against the actual resources in the cluster, meaning that it will try to find SQL claim that matches that exact specification. The second asset manifest is asset install YAML in the AWS directory. So let's take a look at that one as well. That one is essentially the same as what we would do with Cuttle. There are no templates or functions simply because that asset is not reused. It is very specific to manage resources for AWS. There is nothing fancy there, since there is no need to do anything fancy. However, there is one important note here. Take a look at spec resource refs. It is an array of items, and the asset validates that exactly the same items specified here are available in the actual resource in the cluster. They even have to be defined in the same order. No more, no less. It needs to be exactly the same. Now, that's perfectly okay in this specific example, but as you will see later, that can become a nightmare to assert as we start updating resources. For now, remember that there are currently 18 entries in resource refs. That will become important later. Not much later, very soon actually. Now, speaking of updates, let's go back to the test manifest. After the asserts that validated that the resource initially applied and child resources it created are as they are supposed to be, I wanted to update the SQL claim. With Cuttle, that would mean creating a copy of it, making some modifications, and applying the whole manifest again. That's another example of repetition. Now, to avoid that, I used Chainsaw's patch option. So let's take a look at it. This is very similar to customize overlay mechanism. Instead of specifying the whole SQL claim again, I'm saying something like find the SQL claim named MyDB and update it by adding parameters databases with those 3 entries. That allows me to avoid repetition except for the identifiers like API version kind and metadata name. Now, testing that patch could be complicated, but is actually relatively simple with Chainsaw. So let's take a look at the asserdb YAML file that should validate that change. The expected outcome of the patch we applied should be the addition of 3 additional resources spun up by SQL. There were 18 before, and now there should be 21. Now, at this stage, I'm only interested in those 3 because having to list all 21 sounds like a waste of time. That's what I would have to do with Cuttle, but not with Chainsaw. Instead, I can apply filtering. I can say, get all resource refs entries, then filter them so that only those that contain kind set to database are left. I don't care about the others. I want only those. And now that I filtered entries of the resource refs, I can assert that they are exactly what I expect them to be. There should be MyDB, AWSDB 01, 02, and 03. Since the similar pattern should be asserted for Azure and Google as well, that name is assembled using the join function and the hyperscaler variable just as we did before. And there are many other features, but I want to talk about just one more. Only one more, I promise. Just as with almost any other test framework, each step has try, catch, and finally blocks. So far we explored only try, which I used as a mechanism to apply and patch resources and to assert them. That's the backbone that everyone will be using. But in some cases, we might want to leverage catch blocks that are executed in case there are failures, and the finally block that is executed always at the end. Personally, I do not find finally useful in my projects, since Chainsaw automatically deletes all the resources created in the try block. Nevertheless, if you have some additional cleanup to do, that's when you would do it. The catch block is, at least in my case, very useful. You see, when a test fails, the output Chainsaw provides by default is not always sufficient. I often need more, and in this specific case, I need to see all the managed resources running in the cluster as well as the events of the main resource under test. That's why I added 2 catch statements. The first one is a get that returns all managed resources, and the other one is describe that, as the name would suggest, describes the SQL resource with the specific label. Now, to be clear, I could accomplish exactly the same with the script that would execute kubectl get managed and kubectl describe commands. The effect would be the same, and the specifics are probably not important for this story. What matters is that there is a mechanism for me to retrieve additional information in case of failure of one of the assets, and that I can use that information to deduce what I did wrong. Now, I only scratched the surface with Kyverno Chainsaw, and I will leave it to you or there to explore it in more depth, but only after we go through pros and cons. I must admit something. When I first saw Chainsaw, I was not impressed. I was not impressed at all. I thought that it is moving into the wrong direction. I thought that Kyverno JSON query language might not be the best way to express complex logic, and that we would be better off writing those tests in a programming language of choice, which in my case would be Go. That might still be the case. There's still something telling me that I might be better off writing tests as real code instead of YAML interpolated with Kyverno JSON query language. It simply does not seem right to convert YAML into anything it is not already, into anything beyond data structures. Nevertheless, I do think that Chainsaw is, right now, at this very moment, the best tool to test Kubernetes resources. Cattle is simply too limiting and results in too much repetition, which I was tempted to avoid through some really silly workarounds. Hence, even before we go through Chainsaw pros and cons, I can safely say, use it. It has its faults, just as anything else does, but it is a huge step forward when compared to what we had in the past. Now, with that being said, there are a few negative things, so let's start with those first. To begin with, documentation is not very good. I struggled a lot with it. Docs might be the main reason why my initial impressions of Chainsaw were negative. Fortunately for me, folks behind the project were very helpful and made me, how can I say it, see the light eventually. I'm sold now. I'm committed to Chainsaw when testing my Kubernetes resources, but that's not thanks to documentation, but rather thanks to very approachable maintainers. Now, to be clear, almost all projects have horrible docs in their early stages, so I'm not saying that Chainsaw documentation is worse than others, but rather that it is just as bad as most early stage projects. What else? Oh yeah, I'm not convinced that expressing logic inside YAML is a good idea. If we are in need of loops, conditionals, and other constructs, we are generally speaking better off with something like Go or Python or Java or Q or any other language you might be familiar with. That being said, Kyverno JSON query language is very powerful and it works well. It's not something developed specifically for Chainsaw, but rather something that has been battle tested with Kyverno itself. Hence, I'm split between this is great and this should not be done with YAML. And now that I mentioned Kyverno JSON query language, there is also a relatively steep learning curve, at least when testing is concerned. It might take a while until you get a grip on Kyverno JSON query language, which is the backbone of Chainsaw. If you're already using Kyverno, you should have no trouble jumping into Chainsaw. But if you're not, it might take a while until you feel comfortable. Finally, there is no string interpolation. Having to use functions like join instead of simply interpolating strings and variables makes tests harder to write than they should be, and even harder to read, at least by those not experienced in it, right? Now, to be clear, there might be other issues. There are other issues, but at least for me, those are the biggest ones. And frankly, I'm not worried about any of those except my doubt whether to use YAML in the first place. I will explain later why I'm not worried, just after we go through the good things, through pros. The first, and potentially the most important thing about Chainsaw is the openness, enthusiasm, and proactiveness of the maintainers. Now, to be clear, vast majority of the commits are done by 2 people, with occasional commits by a few others, so it's not a big project with massive number of maintainers. Nevertheless, I was impressed to see how proactive they are in reaching to other communities, listening to feedback, adapting the project to the needs of early adopters, and all the other things that projects at such early stage should be doing, but are often not. I asked for some features and some of them were already added to the project while others are ongoing. I wanted bindings, I got bindings. I wanted it to be available as an X package, and by the time you watch this, that will probably be done. I got burned by not being able to use string interpolations, and I'm sure that will be added soon. No, actually, that was added shortly before I started recording this. That's the reason why I said that I'm not worried about the cons, about the negative things. I'm sure that the issues I discovered will be fixed soon. If you discover something, you over there, I'm sure that you'll get the same treatment as long as you let the project know what that something is. Next, templates, bindings, and functions are absolutely awesome. Chainsaw is piggybacking on Kyverno that already has many of those things nailed down, and that's giving Chainsaw a huge boost. Since the project started by Kyverno itself, they have the know-how that allows them to move fast on top of what they already know. Those alone enabled me to greatly simplify my tests that were previously written in Cuttle and to do things that I could not do before. Then there is output that is much easier to read and deduce what's wrong. That output is greatly augmented with additional instructions I can add to the catch block, so the mere existence of try, catch, and finally blocks is important, especially since it follows a common practice in testing. Then there is patching, which helps greatly with constant updates of the resources for the sake of creating more robust test cases. Finally, if you're already using Cuttle, you can switch to Chainsaw without any modifications. Chainsaw can run Cuttle tests as they are. Now, to be clear, you won't get much of the benefits of Chainsaw by only changing the CLI. You will eventually have to rewrite some of the tests or start writing new ones in Chainsaw-friendly way. That's to be expected, right? But what matters, at least to Cuttle users, is that you do not need to rewrite all your tests right away. You can just switch to the Chainsaw CLI right away, immediately, without any upfront investments, and transition your manifests later when you see that you'll gain benefits from the effort. All in all, Chainsaw is awesome, and I strongly recommend it. It has its quirks, but as far as I know, it is the best tool for testing Kubernetes resources right now. The community is very welcoming, and I suggest you to get in touch with them if you have any, and literally any, suggestion for improvement. Thank you for watching. See you in the next one. Cheers.